In this lesson we're going to learn how to differentiate e to the x, and we're going to be using the fact that if you differentiate e to the x you get e to the x. But what happens when we differentiate a product or a quotient with an e to the x, or in fact if we have to differentiate a function of a function using the chain rule with e to the x? By the end of the video you'll know what to do. We learned how to differentiate products and quotients in an earlier video. In this one we're going to use those ideas to differentiate functions of e. So here we've got one factor multiplied by another factor. If I differentiate this I'm going to get 6x squared minus 1, and if I differentiate e to the x I get e to the x. So we're going to have this differentiated multiplied by e to the x. Plus this multiplied by the differential of e to the x, which is the same thing. So that gives us what we've got here. Now what you might notice is we've got e to the x in both cases and both terms, and although you don't have to do this for some courses, if we wanted to simplify it we can take that out. We have e to the x and we have the 2x cubed, the 6x squared, the minus x and the minus 1. Well, what about a quotient? So the first thing to note is that if we differentiate this, we're going to get minus 6x, and if we differentiate this, we get e to the x. So using the formula for the quotient rule, we have this differentiated multiplied by e to the x, plus this multiplied by e to the x minus this multiplied by e to the x differentiated, which gives us this, over e to the x all squared, which is the same as e to the 2x. Now here I can simplify because I can cancel out e to the x and e to the x and one of these e to the x's to leave us with this simplified function here. However, I must stress on some exams you don't have to simplify at all, and leaving it like this would be good enough. Now let's look at some examples of differentiating functions of e where we've got a function of a function. So what we're going to note is if we differentiate e to the x, we get e to the x. So here we might expect to just get e to the 3x squared plus 5. But this isn't an x, so we've got to finish this off by multiplying by this inner function differentiated. And if we differentiate 3x squared plus 5, we get 6x. So that's what we get there. And now we've got this other one where we've got y equals e to the 2x plus 7 squared. So we've actually got a function of a function, but fine. If we differentiate e to the x, we'd expect to get e to the x. So we might expect here to just get e to the 2x plus 7 to the 2. But we've got to finish this off by multiplying by this whole inner function differentiated. And it's just a bracket, so we know what to do. We're going to times by 2, take 1 off the power, and then multiply by this differentiated, which is another 2, which gives us this. So we've got 2 times 2 is 4, so we have got 4 times 2x plus 7 times e to the 2x plus 7 all squared. So we've seen now in these last two slides several situations where we can differentiate e to the x, and it's probably one of the easiest sorts of questions that we can get. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Staying in field with Winfield.